All right, now before we launch into the final bit here, finding the distance from a point to a line, I just want to talk briefly about what it is overall that we're doing. I'm going to give you a visual picture here. So here I have a line and then a point. Now I want to find the distance from this point to this line. Well, there's a lot of, I could measure from here over to here, or here up to here, or here over to here. So how do we measure the distance from a point to a line? Well, say this for me, and this were a wall, and I wanted to say, well, how far am I from the wall? I would measure the shortest distance from the wall, straight to the wall, which happens to be perpendicular to the wall. So the first thing we need to do is to make a line that goes from this point to this line and is perpendicular to that line. So here when I'm working with my GeoGebra, I've got a tool for that. I just click on the point, click, oops, go back here. All right, here. I'm going to click on my line, perpendicular line. Click on my line, click. There's my perpendicular line. I'm going to fix it to this point. Go back to my move tool. So now I've drawn a line that's perpendicular to the original line and passes through this point right here. Now to do this algebraically, we would have to take this equation and find its slope and then write an equation of a line whose slope is the negative reciprocal. So we take the original slope and usually just flip it upside down and then change the sign, positive to negative or negative to positive. So we write an equation that has a slope that's the negative reciprocal of the original and passes through this. That's where we're writing our equation in point-slope form. So our first step here was to take this equation and rewrite it in slope-intercept so we could get the slope. And we take that slope and we basically, again, flip it upside down and change the sign to get the negative reciprocal and then write the point-slope version of this equation right here. So the next thing we'd have to do is we have to find out where these two lines cross. Well, with my handy-dandy GeoGebra tool, it's pretty easy. I just put a point there. That's where they cross. And when you're doing this algebraically, what we have to do is take these two equations and write that they are equal to each other, and then solve for x, and that gives me the x-coordinate for this point. And then I have to substitute that value for x into one or preferably both of the original equations and find out what the y-coordinate is. And that's what we were doing when we were solving equations with variables on both sides. We were practicing to solve the equation that we get when we put the expressions, the x side of each of these equations equal to each other. All right. So once we've done that, we've found this point right here. Next thing we need to do is find the distance from A to that point of intersection. Well, here again, let's see, I just get my distance tool, and I just go click, click, and I get 3.79. That's my distance. But, of course, what you're going to have to do is use the distance formula. And in some of these cases, our points are going to end up being ugly fractions, and that's why we had to practice some distance formula problems that involved some pretty ugly looking fractions. So again, step one, we take our original line and we rewrite its equation in slope-intercept form so that we can get the slope. Then we use that slope to find its negative reciprocal, which will be the slope of our perpendicular line, and we write the equation in point-slope form because we know a point and we know the slope for the perpendicular line. So now we have the two equations for the two lines, and we use those two equations to create a single equation with variables on both sides. We solve that equation to find the x-coordinate for where the two lines cross, and then we substitute that value for x back into both of the original, and we do that to make sure that we get the same answer both times, both of the original equations, and find out what the y-coordinate is. And then we know the x and y-coordinate for the place where the two lines intersect. Then we're going to have to go back and find out what is the distance from our original point A to that point of intersection using the distance formula. Okay. So now, in these next few videos, well, let's go take a look.